So we have a force going up here of 100, and can everybody see that what I'm drawing is behind the line? And then we have a force in front of the line that's going down 100. So what is that, what spin is that creating?
Negative.
It's a negative, because if my fingers curl, I have my thumb pointing in the x direction. So it's 100 times, what's the perpendicular distance?
16.
16, and you said it was negative, right?
Mm-hmm.
Okay, Chris L, question?
Yeah, I was just wondering, how do you know it's negative? I'm just trying to understand the right hand
Yeah,
rule thing.
okay, so let's, so here's my, let's pull this out. Here's my x-axis, right? It's coming this way. So this is positive. So I'm holding it right now. This 100-pound force is out here. It's behind it,
Okay.
right? So I'm going to hold it like this. And this 100-pound force is in front of it. So I have a force going down and a force going up, and what's happening is it's spinning like this. It's spinning like this. Because the force behind it is going up, and the force in front of it's going down. Okay?
Okay.
So then that's a negative.
Huh.
So the force is going up behind it, so think of it as rolling. My force is coming around like this, it's rolling this forward. If it's rolling this forward, my thumb points to the negative x.
Oh, okay, that's how to think of it.
Okay, and everybody has a different way that you're going to be able to understand it better. And I'm trying to do as many different ways as possible. And then if you come up with another way, share it with everybody, because then another 5 people will like your way, probably. Okay. Okay, Chris M. So 100 times 16, and then we have a 100 times
12.
12, right? Because we're looking at, if we're looking at this being in the z direction, we're trying to find the moment about the y. Hey, what did I blow right here? I gotta make sure I put I. Okay? So here we have, so Chris L. Here's the force, I mean the axis. There's a force going behind it going down, so it's spinning like this, and in front going up. If it's spinning like that, Chris M, did you get a
Negative.
negative? So it's 100 times 12, it's a negative, and it comes out to be a negative 1,600 and 1,200, so that's 2,800?
Yeah.
Oh, no, can I add them? Look what I'm doing. Craziness, right? What an idiot. Can't do that, right? Okay, so it's negative 1,600, 1,600I minus 1,200, that's not, yeah, 1,200 J, and the units is what? Inch, pound. So Armando, what's the total moment created? Total moment. What does it come out to be?
Negative 1,600I.
Negative 1,600I,
Negative 1,200J.
1,200J,
And then negative 1,540.
right. Okay, what else? I'm not finished. What's the unit?
Inch pound.
Inch pound. JJ, what are the 2 ways we can represent the moment vectors? One is,
Unit.
okay, so let's go back to forces. Remember the first day of class, or actually before the first day of class, you learned 3 ways to represent a vector, right? So what were they?
Vector form.
One was vector form. One was?
Magnitude and direction.
Magnitude and direction angles, magnitude and direction angles, and the third,
I forgot.
Brandon?
Unit vector.
Magnitude and unit vector. So 3 ways to represent force, go back in our notes. Vector form, magnitude and unit vector, and magnitude and direction angle. But once we got to moments, we only represented it in 2 ways. One is vector form, and the other one is magnitude and direction angles. And what do I mean by direction angles? Iliad, what are direction angles?
The angle from the axis to the
Right, what's the variable for them?
theta.
Theta x, theta y, and theta z. So far, Armando gave us the total moment. Chris Z, which way did he represent it? In vector form. So now let's represent it as magnitude and direction angle. So Jill, we have it in vector form, and now we have to find out what the magnitude is. What's the magnitude of this moment? How do I figure that out? I have the I, J, and K components. Not the force, just the magnitude of this moment. Think of it, whenever I ask a question in moments, think of it in terms of forces, if you're more comfortable with forces. If you had the X, Y, and J component, no. X, Y, and K, no. X, Y, and Z. If you had the X, Y, and Z component of forces and you wanted to find the magnitude of the force, what would you do? Square them all. So it's 1600 squared plus 1200 squared plus 1540 squared under the radical, and what does it come out to be? Somebody do it already?
25.4.
Say again?
25.4%.
2524. Let's skip decimals now. That's the magnitude, and how would I find the direction angle? Santiago? So I have the X, Y, and Z component, and I have the magnitude. How would I find theta x? How am I doing over you guys over there? Are we just on,
Yeah, there's fine.
what's theta x?
I think you will need to form a triangle between the 2 forces and multiply by the I value.
I don't really know what you mean by the triangle, but we have the x component, we have the y component, and we have the z component, and we have the magnitude.
Okay, so magnitude times the cosine of the angle.
So the cosine of theta x is going to be equal to the x component of the moment divided by the magnitude of the moment. So theta x is going to be the inverse cosine of negative 1600 over 2524. It's a negative value. Should I get, what should I get? An obtuse or an acute angle? Obtuse. What do you get? Hmm? 129, but direction angles, we already decided that we're always going to keep 1 decimal place, so give me 1 decimal place. 0.3? Okay, and now calculate what the theta y and theta z are, because we need to report what they are as well.